would care about chemistry at all. Okay? Now, I know for a fact most of you are not in here because chemistry is your favorite subject. I bet money on that right off the bat. Because, well, you're not majoring into science for one, but also it's pretty rare to find 30 people who all like chemistry. Okay, so you're here for a variety of other reasons, and we'll talk about what those are and so forth, but right off the bat, I completely understand it's a general education requirement, right? There you go. Now, does that mean this class is going to be a waste of your time? I hope not. Okay. There are things we're going to talk about in this class that will apply to your lives, your daily lives and so forth. Every once in a while, a student will come in after a lecture and just be completely surprised that they actually talked about something that we talked about during class and so forth with like friends, like real people, not just a faculty member. So that's my goal. Okay. You are going to learn chemistry, some very basic chemistry as we go through the course, but also I want everyone to kind of, I don't really want to say appreciate because that's not the right word, but understand at least at some level chemistry is important and science in general. And that's kind of the whole purpose of the course as we go through and so on. So what I thought I would do is just kind of go through some of this stuff on the first day. You probably have already noticed, and you will notice very quickly, I run my classes about as informally as I can. I'm not from a background of stuffy teachers sitting up front talking at students. Like, I hate that, so forth. So if I'm talking too long and so forth, interrupt me, please. I don't want to stand up here and talk for an hour and a half, just ask questions and so on. And we'll get through all that type of stuff. Hopefully, by the end of the term, you'll be brave enough to just speak out. And in an ideal world, argue against me with various things. I have no problem with that at all. My job is not to stand up here and tell you what to think. That's not what a teacher should do, at least not in my opinion. My job is to just give you the information so that you can kind of have an informed decision on your own. Okay? So as we go through the course, that's kind of the way it works. When we do things, and we will do things such as clipping assignments, we'll talk about those later on, but where you'll present your ideas about various things, the only real rule that we have with that is you have to be respectful to one another. You don't really have to be that respectful to me, I don't care that much, but you do have to be respectful to one another, and I will just all of a sudden kick you out of class if you're shouting at someone or something. Okay? Sounds silly, it's only happened once in the decade I've been teaching here. And I don't think it was about the topic. It wasn't that exciting of a topic. I think it was just two people that were angry at each other. Okay. So let's go through a little bit about all of this as we go on. One other thing I should mention is from time to time you're going to see Chemistry 105 in today's talk. That's because I didn't want to make a separate set of slides, and it's the same thing. Okay, so you guys can just ignore that, or you can, if you really want, you can pretend the course is 105, even though that's something different. So I'll kill the lights. If you fall asleep, I'll yell at you or something. I don't know. I had a professor in undergrad. I'll use my stories of my life and so forth throughout class. You're kind of stuck with it. I went to a small undergrad, and just so you guys are aware, the total size of the school was like 1,200 people. Right? So when you think about that, that's smaller than the freshman class here by multiples at any point. So it was a relatively small school and things, so it was really, really informal. We called the professors by their first name, which I guess I never actually said my first name. My first name is Brad, by the way. Please feel free to call me Brad. It's not a big deal. Dr. Steve is my actual name, which you probably can't see there. But you can call me Brad. Hey, you, help. Anything along those lines is perfectly fine. Okay, it makes no difference to me. You're wrong. Maybe if you're brave. I don't know. No one's ever said that. But yeah, it'll be an interesting day when that happens. I will smile. Okay. But, so please feel free to call me by Brad, whatever you want. It makes no difference to me. I've heard it all. You know, after you taught as long as I have, you really kind of heard everything. In one of my reviews once, my favorite one, the student wrote that I was distracting in class because I didn't iron my shirts. So from that point on, it's all uphill. So there you go. I don't iron my shirts, by the way, so if that's a phobia of yours or something, then let me know, and I don't know. I don't think I'll start ironing my shirts, but we can work. I don't know what I would do. Yeah. That one just sticks in my mind because it was unusual. I didn't expect it. Also, a couple other things about that. I always use the example of going to the bathroom. Don't ask to go to the bathroom because I can't say no. I mean, what am I going to do? Say no, you can't go to the bathroom. Just go to the bathroom, come back. If you've got to take a cell phone call, go take a cell phone call, come back. If you're falling asleep and you need to like move around a little bit to wake up, go do it, okay? Don't be a huge distraction to everyone else in the class, but you know, at the same time, by asking for those types of things, you're kind of stopping the whole flow of class and everything, and then it's a distraction in and of itself. So just do as you will. The other thing I'll mention, since I just said that, is laptops and so forth. Obviously I don't care if you have laptops and you use laptops and so on, but just be aware of the neighbors around you. Like a couple semesters ago, I had a student complain because he sat next to another student and the other student was screwing around on their laptop all class playing video games. I was like Dragon video games or something. I don't know. I don't remember. But it was very distracting to him. So he brought it up to me and so on. I told him to move. But that being said, realize that that's not always a possibility for everyone. The class isn't super full, but if the room was full or something, that would be an issue. So just be polite and, you know, not affect each other as you will. Okay. I don't really know how to say that because I don't want to sound like a grandparent or something. But at the same time, I understand if you're bored, you may end up playing solitaire. And I'm not going to walk to the back of the room to see what people are doing on their laptops or put mirrors up or something. But just, you know, be polite. Okay. Let me find my pointer stick. Handy. So here we go. Just right off the bat, why would we want to take a chemistry class? Well, from the puristic point of view of a chemist, I think you should want to take the class because chemistry is all around you. Everything you do in the day has something to do with chemistry because chemistry has to do with matter. So anything you interact with is going to be chemistry in some way. Now, you may not think that's true. However, you very quickly realize when I ask questions such as this, how many of you drove to campus today? Okay. All of you got to campus because of chemistry. The obvious choice of gasoline in the car to power it, but also tires. Imagine if tires were made out of different things or had different properties and so forth, how that would change things. The ability to go over long distances. You may not think 10 miles is a long distance, but 100 years ago, 10 miles may be the entire distance someone travels in their lifetime. Think about how sad that would be, actually, just 10 miles. But that has changed dramatically with the development of cars, gasoline engines, steam engines, electric engines. I'm not exactly sure how you got here, if it was electric car or gasoline or whatever, but so be it. If you didn't take a car to school, your life has still been affected. I would guess most of you probably brush your teeth in the morning. Toothpaste is chemistry, toothbrush is chemistry, water is chemistry, teeth are chemistry. You really can't get away from it, whether you like it or not. Okay? So it's all around you, and just understanding the basics. This class is not going to cover advanced chemistry. It's not even going to cover second year chemistry from like a chemistry major type of view. It really doesn't even cover most of first year chemistry. This course is kind of at the level of a high school chemistry course. Now, high schools differ very greatly from one school to another, so it may be a little higher than your high school, it may be a little lower than your high school, or whatever. But that's the general idea of it. It's not meant as a course to trip people up. and become a major issue and so forth. Now, you do have to do the homework, so you have to, I would say, attend class, pay attention, these types of things. But that being said, I don't think there's any reason anyone should fail the course. Normally, people who fail the course stop attending. Like, they don't take the final. Okay? If you don't take the final, don't expect to pass the course, obviously. If you don't do the topic paper, which is 20% of your score, that puts a big hurt on your overall ability to pass and so forth. So if you just show up, do the work, pay attention and so forth, I would expect just about everyone to pass. Again, usually if you don't, there's some reason for it. And throughout the course, we're going to talk about the fact that chemistry is all around us. And this chemistry is going to affect your jobs, no matter what it is. Now, one of the great things about this course is we've got people from all different backgrounds, so we can talk about anything. I don't know, probably 5-6 years ago, there was a student whose family made moonshine, and he was very, very knowledgeable about it. So we ended up talking about it for an entire day. He knew more than I did. It was kind of weird, but so be it. And he was willing to talk about it, so people were asking questions, and he was answering them, and so on. But your job. So I came up with this challenge for students a while ago when I first started teaching, and I said basically this. If you can come up with a job that you would do in your life, or a hobby, or anything along those lines that does not involve chemistry, then you can just have an A for the semester and go home. Okay? And that perked everyone up right from the start. Okay? But then I was told I can't do that. So now I just make it a game to see if anyone can come up with something that does not involve chemistry. Any ideas? Think about it. I'll let you guys think about it for a while. A couple of common ones that come up. One of my favorites was stamp collecting. There's a quote that has to do with that, but stamp collecting. And stamps themselves, right? When you put the stamps in the special stamp holders, I don't know what they're called. It's to maintain them and so the colors don't fade and so forth. So you have the dyes on the stamps. Different dyes on the stamps have to do with chemistry. The materials, so they don't fade, they keep sunlight out, has to do with chemistry. And then the adhesive on the back, obviously, is chemistry and so on. Another one I get a lot of is sports. For some reason, a lot of the members of the golf team like to take this course. So I've had like 15 papers written on the chemistry of golf balls and the various things associated with that. So with the Olympics last week, you've got chemistry basically in all of the different sports and everything. The best answer that I've ever gotten is a theoretical mathematician. And when I asked what that meant, they said that it's someone who just sits around and thinks about math. Okay.
They get paid to think about math?
Apparently there is such a thing. I was not aware of this. However, it sounds like a decent job to think about math. So how would someone who sits around and thinks about math involve chemistry? Do you want to think of a way? Be brave.
Their brains, functioning.
Their brains and the functioning of the brain. So when you have a thought, for example, it's electrical impulses, it's moving through neurons in your brain and so forth, that all comes down to chemistry. That's actually the reason I could have the game in the first place, because no one could ever tell me a job that doesn't involve chemistry, because anyone who's doing a job is chemistry. So every one of us in here is chemistry going on. As I walk back and forth and pace in front of the room, I'm using energy that's coming from the food that I ate and it's being converted to energy for me to move. The muscles that I'm using so I can move back and forth, as well as chemistry. And then talking is chemistry, and even the thought of talking is chemistry. So chemistry really is all around us. And I would encourage you throughout the semester to think of ways that chemistry would affect whatever you want to do in your life. It doesn't really matter what it is, but at some form it will affect you. You guys kind of see that? One of my favorite examples about chemistry in an unusual place is violins. So do you guys know who Stradivarius was? He made violins, very famous, very, very valuable violins. I have a friend who plays the violin, so it caught my interest and so forth. But, okay, the reason I'm laughing is one of my favorite things that she does is, let's just say we're hanging out, okay? Maybe at a bar or something, and if she has her violin, she'll actually play all of the theme songs from Super Mario Brothers, like level 1, level 2, level 3, going through on the violin. It's a big hit. She can get all of her drinks paid for the night by playing the various songs. But going back to Stradivarius in chemistry, one of the reasons he's so famous is because of the waxes and seals that he put on the wood when he made the violin. And when you change the material, either what the violin is made of or even the coatings on the violin itself, it changes the sounds of them. So violin, like very, very valuable violins, you have to be careful of because of the wax coatings and so forth, and that will actually change the sounds that come out of the violin. So sometimes they pop up in unusual ways. The third one here, that's the reason you're probably all in this room, at least to some extent. 99% of you is required for your degree. It's a general education requirement. I'm perfectly fine with that. I believe in general education requirements. You may not think that it would be useful. However, I hope through the term, you can see some use in the course. I had to take a course in undergrad called The Art of China and Japan. It was very invigorating. We looked at photos of artwork, not even the real artwork, we looked at photos of artwork, which I always thought was kind of weird. Looked at the photos of artwork and we had to memorize the time periods and who did it and all that type of stuff. And I thought it was the most worthless class ever. In the end though, I actually traveled to Japan and I stayed at a temple and ended up talking to one of the monks there about the artwork in the temple. And I actually knew something about it because of that class. So sometimes what you think now would not be useful for you in the future actually can be useful in, again, in surprising ways. Another class I took for my general education was medieval history. And I had to learn, have you guys ever heard of something called flying buttresses? So on Notre Dame, the Cathedral of Notre Dame, they've got the wings that come out the side and then come down and it holds up the sides of the churches and it allowed me to make them taller. Those are called flying buttresses. That allowed me to pass a course just by doing that. So you never quite know what will actually be useful or not. And then finally, in today's day and age, technology and science is very, very commonplace and people talk about it all the time. Okay? This semester, we'll be hearing a lot about politics because of the presidential race here in the United States. And already there are numerous examples of chemistry and science being discussed in terms of the political races. One of the largest ones is greenhouse gas emissions. So we can talk about that a little bit later on once we have a baseline of our chemistry down. But there are other ones. For example, nuclear waste. Does anyone know what the plan for nuclear waste in the United States is?
Underground barrels.
Underground burial. So the name of the plan is named for where it's going to be buried at, and that's called Yucca Mountain. And Yucca Mountain is basically a hole in the ground that we're going to take our radioactive waste to and bury it there. And then hope that no one finds it, I guess is the answer. So that has been in the news in the last couple of years. Yucca Mountain exists, and Congress said, well, we'll just stop it. So they canceled the project, and then a judge said, well, you can't cancel it because you don't have an alternative. What are you going to do with all the waste? So they said, okay, we won't cancel it, we'll just give it $0. So Yucca Mountain is still the official plan of the United States, however, there's no money for it. So nothing's being done about it because they couldn't just cancel it because of the judges and so forth. So that is another one. There's actually a lot of science and technology in politics. Does all of that make sense? Just the gist of it, the basic gist and so forth. Now, I'm not foolish enough to, assume you all agree with me on every point, especially at the beginning and so forth. So that's that. But you kind of see where I'm going is what I'm thinking about. Okay, so this was an example I did a couple years ago before this class. I thought, well, I'll just go to the news and I'll pull some articles and talk about them. And this semester I went and I said, okay, I'll do the same thing. I'll pull some news articles and talk about them and so forth. And then I went to replace these articles, and then I realized very sadly that most of them are still in the news. So this is from 2-3 years ago. So the first one, a milestone in Africa, no polio cases in the last year. This was in the news recently within the last month because they found a couple new polio cases in Africa. So they're afraid that polio may be starting to pop up again in Africa after a couple years ago they thought they had gotten rid of it. Colorado spill highlights old mines. Okay? We've had numerous cases in the last few months of mines, something happening to them and poisoning groundwater, things along those lines as we go through. Fracking, all right, well, that still is around. Just recently, Oklahoma scientists came out and said definitively that fracking was causing earthquakes, an increase of earthquakes in Oklahoma. The fracking industry said, well, no, that's not right. So that's still in the debate right now. We don't hear a lot about that in the politics because there's not a lot of fracking going on here, for example. But we do hear about oil pipelines and that type of stuff as well, as we're moving oil across the country. Climate change and Tanzania coffee beans, I don't really have an update on this, but I assume that they're still in trouble if they were in trouble then. Climate change hasn't reversed in the last couple of years. This one has to do with the nuclear bomb that Iran was supposedly trying to make. And just this last week, they were talking about the money going to Iran and so forth as part of all of that. So there you go. And you can see it throughout newspapers all the time. So if we, for example, go to a website, anyone have a favorite newspaper? Anyone know a newspaper? Okay, so I'm just going to choose the New York Times. And the reason I'm choosing that is because, well, it's easy to type. But the other thing is that in the next couple weeks, they're going to start giving away New York Times and USA Today newspapers in the building. And one of the assignments that we're going to do in this class is called the clipping assignments. So in the clipping assignments, what you're going to be asked to do is go to the newspaper, find an article on something scientific, and write a one-page summary of it. So half the page will be information about the article. The other half of the page will be not information about the article, but your personal thoughts on it and so forth. Okay. So it doesn't have to be the actual newspaper itself that you go to, but some sort of news article, either online or you can use one of the newspapers downstairs as well for you. Okay, so the New York Times. Here's today's New York Times. Right here. Let me see if I can make this a little bigger. I always go the wrong way to start with. Look at that. Right there is an editorial on the Iran and the money having to do with the nuclear arms that they were talking about. Not purely scientific, but has a scientific twist to it. If we go down, okay, don't change. Pandas. We like pandas. Go back. Okay, right there. Look, right there. Okay, that's wind power. Okay, the idea of developing energy from wind, that's a huge issue in the scientific world and whether or not we should be doing it. And politics. Do you guys know why most wind farms are not made, like if they're proposed, why they're not made in the United States. They're not made because of the residents around the area of the wind farm don't want to see them. So they're usually made or planned to be made just off the coast because that's where the winds are strong along the coastlines and so forth. But the residents there who are used to seeing like the empty ocean or the empty body of water in the Great Lakes and so forth, they don't want to see the wind turbines out there. So they block it on a local point of view. Okay? So that's a pretty big political thing wherever you are. My grandparents live in Iowa. I'm originally from Iowa, so I'll talk about it from time to time. In their home county, they built this huge wind farm, and they make enough energy for 3 counties around them, and then they sell it to the other counties and so forth. I was so proud of them. I came back and told all the biologists about it, and they were horrified. I thought, well, it's an environmental thing. Why aren't you for this? Does anyone know what the knocks against wind power would be from a biologist?
Kills birds.
Kills birds. So poor birds, I don't want to get graphic here. They go to the turbine and it's spinning very fast and it doesn't end well for the birds. So they were not very happy about it. The other thing, and from a chemist's point of view, the other thing about wind turbines is what are they made out of? Anyone know? Seen one? It's not. Okay. Usually there's some steel or something that's the internal structure, and then the outside is all made out of plastics. Well, plastics actually come from oil. The chairs you're sitting in are plastic. They're from oil too. They're a derivative of oil. Almost all plastics originate as a form of oil at some point. So you're using oil to make the wind turbines so that you don't burn oil to make the same energy. And it's a huge debate on whether or not you're actually saving oil or not by doing it as you go through it.
Why do they have to make it out of plastic? Like,
Because they're lightweight, if they use something else other than plastic, like a metal spins, it's too much mass to get the momentum going for them to turn like they do. It's kind of a balancing feature of it. You would think there would be something else that they can make it out of,
hemp
but
or something? Like, because can't you use hemp to make like concrete and things like
you
that?
could,
So, like,
but what they're doing in that case is they're putting the hemp inside the concrete and acting as a secondary structure for the strength of the concrete, which makes it stronger, but you still got the mass of the concrete there. Fiberglass may be an option. I don't have an answer for that. So yeah. So I think it's just the ease of making it and so forth is the reason why they're doing plastics. Okay, should you charge your phone overnight? Well, that is batteries. Batteries are very basic chemistry. It's one of the things that we can talk about in the course if you guys want. A few years ago, no one cared about batteries, but now people are caring more and more as they go on. The Rio Olympics, okay, as I've already said, you've got all the chemistry of the sports and so forth associated with it, but this year you also had water quality. If you remember a few years ago when the Olympics were in Beijing, there were huge concerns about the air quality and people running like the marathon outside in the polluted air and so forth. So as you just go through, you can find all kinds of different articles. Bagels, if you're hungry. Bagels are there for you. At the New York Times. Now, from our advertisers though, but something about fracking there. So you can see that as you go through the newspaper, this is just the first page of the newspaper, it's not even the science and technology part of it. You can find all different types of articles about it. I would highly encourage you to look at newspapers, and not just newspapers from the United States. Now, because of the internet, which sounds kind of weird when I say it like that, but realize when I was a student, we didn't really have the internet to use, at least like college and beforehand. We didn't really have the internet for this type of stuff. Now with the internet, you can read newspapers from all over the world. And oftentimes, they're going to show different spins on news stories and stuff about the United States because they're not inside the United States. And you can look at it differently. So it would be Well, what I do is I try to look at something from the United States, something from England, which is easy because it's in English, something from the Middle East, and then something from Asia. So I've got a web page link thing, and it's got 4 different newspapers from different parts of the world on it. I can just click through and see the different articles. You'll really be amazed at how different some of the different stories are. And sometimes outside the United States, they care a lot about a story in the United States that we don't actually hear about on any given day, just because of whatever the reason is. Okay, so that's the New York Times. The BBC is a good one from England. There's several of them from Japan that you can read. The Middle East, I use I can never say it now. Never mind. Just, you'll find it. Okay. So there you go. As I said, we'll talk about the clippings a little bit more and so on. Anyone have a comment or anything? No, everyone's still awake? It's rough. Second day. How many people, anyone, this is your first class of the week? Yeah, several people. I know that quite a few students do Tuesday, Thursday schedules because of their outside life and so forth, so that makes sense. This is my second, so that's where we are. Okay, so the point of that was that you can find chemistry in the news and so forth. As a personal plea to you, I'm going to show this slide. This was a scientific study done in 2008. The United States is not particularly strong in terms of scientific knowledge of the general populace, which is another reason a course like this is so important. These are basically questions and then the percentage that got the question wrong. The first one's not too surprising. 14% thinks that sound travels faster than light. Light travels faster than sound. You know this because lightning strikes. You see the light before you hear the lightning. So, straightforward there. Now, skip down. This is the one that annoys me. 33% of Americans think that the Earth does not go around the sun once a year. Okay, a third of Americans got that question wrong. It's surprising, isn't it? Because by definition, a year is the amount of time it takes for the Earth to go around the sun. That's what a year means. So I just, personally, I want everyone to know that in 1 year, the Earth goes around the sun once. If you weren't aware of that, then you are now. Down here in this one, it's kind of interesting because of current events and so forth. This is that 49% of people believe that ordinary tomatoes, I did that yesterday too, ordinary tomatoes do not have genes. But genetically modified tomatoes do have genes. Genes are what makes living things into what they are. Okay? Every living thing has genes associated with it. Okay? That's how they live and how they grow and so forth. So ordinary tomatoes absolutely do have genes associated with them. Genetically modified tomatoes is when someone goes in and changes the genes in some form. So it's not surprising to me that 50% of people got that one wrong, but I wanted to point that out. Because a lot of times you see things, you see those things on Facebook, those quick pop-ups or something that says that someone doesn't want food with chemicals in it. All food is chemicals. Okay, that's just the way it is. They don't want food with genes in it, What they mean is they don't want genetically modified foods, which is another whole debate we can have. But they're just, if you don't want food with genes in it, you'd be eating rocks. Is basically the way that it would be. Okay. And here is actually, so these are the grade levels of science for the people. 34% of people did not test at the expected level for a fourth grader in science. 21% didn't test as a 12th grader for science and so on. So the United States does have a very large problem with scientific literacy, which is another reason why a course like this is so important And things like general education is important. Because even if you're going to be an artist, for example, it's useful to know about science and understand the basics of it. Don't worry about this. Does that make sense? Well, broad, educated people. Art of Japan. I don't use it on a daily basis by any means, but from time to time it comes in useful. So one of the other things that I want to address right off the bat is this perception that chemistry is hard. Many of you probably have heard that chemistry is hard. Many of you, if you went and told your friends you're taking a general education course, and in that general education course you chose chemistry, they would say, why would you do that? Choose something easy. Well, I personally don't think chemistry is hard, but obviously I kind of like chemistry a lot. I have some ability in chemistry. So that's not really a very good definition of what's hard or not. But I do think that it kind of depends on the individual person. Some people will find it very easy. Some people will find it very hard. I, for example, find Spanish very difficult. I took 4 years of Spanish in my schooling, and I think I learned 3 words, one of which I was told yesterday was wrong. So now I'm down to 2. And I really think I got them from Taco Bell. Okay? Caliente is one of them, and I know I got that from Taco Bell. And perro is dog, which I don't think came from Taco Bell, but I know that one for some reason. It's just hard for me, Spanish. I'm not good at foreign languages, much to my chagrin. You guys all have strengths and weaknesses. Some of you, I should have asked, is anyone a Spanish major? Is Perro right?
Yeah.
Okay. It's
It's funny to hear you say it like that.
I know, because I don't roll my R's. I know that, I just can't do it. So, do you know what bear is? Bear, that was the one I got wrong yesterday. I thought it was oso.
No, that's right.
Oh, yeah. My class lied to me yesterday. They'll be hearing about that. Now I'm back to 3. They don't make any sense. You can't make a sentence out of them.
You sure there's maybe not a 4th that you might be not giving yourself enough credit for?
Probably.
Like hello, like.
Hello is, oh, no, wait, I do know. I know a whole sequence because we said it every day at the beginning of Spanish class. Hola, ¿cómo
Yes.
está?
There's 2?
That's all I know. Now, I'm all
I guess the
nervous.
5.
If you guys ask me outside of class, I'll be able to do it. But the point is that people have different strengths and weaknesses. And in this course, we are not going to be doing advanced chemistry in any way, shape, or form. We're going to be doing relatively straightforward chemistry, basic chemistry that I consider at a high school level. I think it is within the grasp of anyone to go ahead and do it. Okay? So why do people think chemistry is difficult? One of the main arguments I would make is you're not exposed to it early in life. So what year did you guys start studying chemistry?
Middle school?
High school, a middle school, junior year, something like that. Okay, so if you have to wait that long to take a course, then it must be hard, right? Like if you can't get to it in first grade or so forth, you got to build up to it and so forth. People think that it's hard. That's not the case. We're exposed to chemistry from a very, very early age. We just don't call it that. I've got a 5-year-old at home, so I'll use him for examples from time to time. What happens if my son leaves his Play-Doh out without putting it back in the container?
Dries out.
It dries out and it gets hard. Okay, that's basic chemistry right there. You can very easily talk about that in a chemistry point of view. The water leaves, the properties of the Play-Doh change. Okay? That's a physical change right there. That's chemistry, but we don't use it in those terms. We talk about boiling water and cooking all the time. Even when you're young, you sometimes cook with your parents and so forth. You put it in the microwave and cook something. That's chemistry. But again, we don't use chemical terms for it. And it's all around us all the time. We just don't really use, think of it in terms of chemistry. Also, there's math. And math is very scary for a lot of people. If you are a person who likes math and you like doing math and so forth, I'm sorry, we're not going to do a lot of math in this course. We do the bare minimum to get the idea across. And when we do it, we talk about it pretty extensively on how to do it and set things up and so forth, so that you just follow the basic steps and you go through the problem. Here's my example for the most difficult math that we will do in this class. All the math we do is algebra based. There's no geometry, well, there's no geometry really, there's no calculus, anything like that. So if you can solve this problem, then you're doing good in terms of the math for this course. So how do we go about solving the problem?
Subtract 2 for 26.
We're going to subtract 2 from both sides. Exactly. 24.
Divide,
So 4x is 24.
divide both sides by 24.
Divide both sides by 4. And you end up with 6. So that is really the most advanced math we'll do in this course. We do multiplication, we do division, we do addition. I can't actually think of any time we do subtraction. But just the basic types of things as we go through it. Now, if you do have a problem with this, there's nothing wrong with that. Just let me know and we'll run through some practice examples and we should be good. We'll get caught up without too much. If at any point you feel like you're falling behind or you're having issues or something, let me know so that we can get caught up without falling further behind. This course is very, very sequential. So we start with simple things. What is chemistry? What is science? Okay. Then from that we go on to what are atoms? And then we go what are molecules? Then we start working with molecules and then using molecules to do things. So if we get to the point to where we're using molecules to do things, but you don't understand what molecules are, you're in trouble. Okay? So try not to fall behind in the course because it constantly builds upon itself and it's much more difficult to get caught up later than earlier. Okay? So keep that in mind as we're going through things. So math, the other part of math is in chemistry, you're never going to see a problem that's 4x plus 2 equals 26. There's just no problems like that in chemistry. They're all story problems. I understand everyone hates story problems. I don't like story problems myself. We are going to use, it's actually called dimensional analysis or unit analysis to set up problems going from a story problem to the math, and we'll spend 2-3 days actually talking about how to do that. So don't panic. It's really 3 steps that you got to do when you're going through, and we'll work with a lot of examples and so forth. In this course, probably 50% of the course are examples and me working things on the board and so forth for you. So keep that in mind. I've had in the past students who just get the PowerPoints off Blackboard and think they're okay, but for most of the course, you'll be missing like 50% of the course because of that, because of the various things. So at least at a minimum, make sure you get the notes from someone else in the course so you can see the examples and so on that we work on as we go through it. Okay, so we'll be working on all of that. I know if you've had dimensional analysis or unit analysis before, it's probably not your favorite thing. We'll simplify it so we can get through it without too much problem. Second languages. As I said, I don't like Spanish. Chemistry is sometimes a second language for people, and you may not know all of the words, so we'll treat them like vocabulary as we go through them. Some words you do know. Conductivity, for example. You know what the word conductivity means? It means that it either carries electrons or heat. Right? It transfers some property through it. A solid. You know what that word means? That's a chemical term. So we'll use primarily words that you already know. There are a few, though, that you may not be familiar with. Exo and endothermic, that is whether it gives energy up or takes energy in. That may be a new one for you. Density, maybe. I don't know if you know what density is or not. I assume you probably do, but in terms of the course, one thing I didn't say, I skipped past earlier, is this course is set up for people who have It's set up as, bless you.
Sorry.
No worries. It's set up as if you've never had a chemistry course before. Okay, so we start at the very, very basics, and then we work forward. For some people, that's going to be boring for the first couple weeks because it's a lot of material that you've already had, but then we'll start getting into new material and so on. So don't give up on it because I don't want someone to get swamped once we switch over to whatever is new for you. And it's going to be different for different people. We have people in here who have never taken a chemistry course before. No chemistry at all. And it's perfectly fine. We can start at that level and work our way up. Okay? We also have people in here who have taken AP chemistry before. Okay? Some people probably have gotten 3 or 4s on AP tests in this course. They're here because they need the general education and they want the easy credit. Well, great. However, realize that not everyone is at that level. So when we do math, I will be doing it stepwise as we go through things, okay? Just to make sure everyone's okay. It's easier for me to bring the level down and then have everyone work their way up than to just start at the top and then leave people behind. That makes sense. There will be material, I assume, that's new for everyone. I've never had a student in here who has had something that didn't get something new out of it. If nothing else, some of the stories and histories and so on as we're going through. But vocabulary and so forth, we will use the words a lot, so you'll pick them up as we're going through them. It's not like Spanish class where they tell you the word and you say it a couple times and then you move on to the next word. The words will all be part of our individual lessons. And then finally, the last reason, I actually think is the reason why most people think chemistry is hard, because other people tell you it is. When you hear all the time that a subject is hard, then you generally think that it's hard, okay? Whether you've had it or not, because other people are telling you that. So hopefully in this course I can kind of dissuade you of that idea, and you can start telling people chemistry is not the hardest thing. Okay? I don't think it is. Okay, so we'll work through these various problems as we go through. You guys heard all of those before? Seen those at various levels? None of them do chemistry any good in terms of making you think that it's not difficult. Some people will think the course is difficult. I want to be honest with you. Some people will think the course is difficult. They've never had the material before. They don't do the homeworks. They don't show up for class. Or it's just difficult for them. That happens sometimes. Okay? We'll work with you. If you are someone who's having difficulty in the class, ask questions during class. If you're shy and you don't want to ask questions during class, then come see me after class. Come see me in my office hours. Shoot me emails if you want. Whatever. If you're too shy to come talk to me, write it on a note and slip it under my door, and I'll just cover it during class as we can and so forth. I'm not a person to try and keep things away from students. If there's something that can help you learn, let me know, and I'll do my best. So the goals of the course is to convince you chemistry is important and it will affect your lives. While it can be complicated at the extremes, the basics are realizable for students. Like, you guys can grasp the basics, I think. We don't want to get lost in the math, so the math will be downplayed as much as humanly possible as we go through the course. And then we'll be using real-world examples so that you can see that chemistry ties into real-world stuff. So as best I can, a lot of the course is set up as real-world type experiences. All this stuff making sense so far? You agree? Okay. Let me see where I'm at. Okay. What time is this class over? Now. Good answer. What is the official time the class is over? 12:05? Okay. 12:05. So give me a little, I want to do a little bit more, but before we leave, we have to talk about the textbook. Okay, so if it hits 10 till and I haven't stopped, then stop me, because I have to take a little bit of time to talk about the textbook. So the final thing is I want to prove to you, or try to prove to you, that chemistry affects the world in general. So here's a photograph that I took. This is a museum in Athens. Looking at it, can anyone tell me what the photograph is of?
Looks like swords.
Swords, that's exactly what they are. They're swords. And they're swords from the Bronze Age. Now, why is that age called the Bronze Age? Anyone know why?
Swords made out of bronze.
We'll go with that. Swords are made out of bronze. I think what you're trying to say is better swords are made out of bronze. Okay? So during the Bronze Age, people, scientists, I guess, figured out how to make bronze. Bronze is stronger than the previous materials that they had. So if a farmer had bronze tools instead of stone tools, he could cultivate more land. If you cultivate more land, you can then make more food. If you make more food, you can support a higher population. Weapons. If swords are made out of bronze, they will break wooden swords and wooden shields or stone swords. So if a soldier has a bronze weaponry versus someone who has the previous weaponry, the bronze soldier will usually win because of it. It also holds an edge better, which is very useful. So the reason the Bronze Age is called the Bronze Age is because the development of bronze allowed for specific civilizations to overpower other ones and kind of influence where the world is going at that point. So that's the Bronze Age. The reason you know it's bronze, by the way, is the fact that they're green. That's from the copper inside the bronze. So over time, copper will turn green. It's called a patina, something like that. And that's what we're seeing there. That's why the Statue of Liberty turns green, by the way, the same reason, and so forth. Okay, so there's that. Now, can we come up with other examples? Other examples in when chemistry has changed the world? Any ideas? Think back in history. Yeah.
The atom bomb?
The atomic bomb completely changed the world. Now, the current age that we live in is generally called the nuclear age, and that's because of the effects of the atomic bombs as well as atomic energy, okay, the ability to make energy and so forth from it. If you think about the world before and after the development of the atomic bomb, they're completely different. One very easy example of this is the United Nations. Okay, so the United Nations, we all know what the United Nations is. The United Nations Security Council is a smaller subgroup of the United Nations. Anyone know what's special about most of the people in the United Nations Security Council? They just so happen to be the countries of the world that have nuclear bombs when you look at it. The rotating one doesn't, but most of the other ones do as they go through. So nuclear power and nuclear weapons have changed tons and tons. Anything else we can think of?
What about chemical plants?
Chemical plants and the ability to make chemicals, be it medicines, fertilizers, anything like that. It's a huge, huge effect on the world.
Vaccinations?
Vaccinations. We were talking about polio earlier. Vaccinations for polio and so forth have affected things. Okay. Others, yeah. Steam power. The development of an engine. Okay, we talked about cars being able to bring us to school and so forth at the beginning of class. They started off as steam as one of their possibilities for power supply. Nowadays, almost all power generation is actually steam power. We don't think of it that way, but it is actually steam power. Steam is what's actually turning the turbines inside of a power plant. How they make steam is what's different. So you either use nuclear energy to make the steam or you burn coal or wood or something to burn the steam. But actual generation is based on steam. Okay, going back in time, much further back. These are all modernists. Any history majors? Do we really not have any history majors? Well, I don't know how many history majors the university has. So, okay, going back, very common one that's pointed out is gunpowder. The invention of gunpowder, if you will. So if you look, chemistry has affected warfare in a lot of different ways, and that's affected the world in general because of the outcomes of wars and so on. One that doesn't affect wars and so on, and I think one of the biggest effects in society in general is birth control. If you think of the world before and after, the effects of that are astronomically large. There's a book out there called Napoleon's Buttons. And what this book does is it takes 12 different, I think it's 12 different chemicals, and looks at how those chemicals changed the world. So cinnamon, for example, is one of them. Almost all of the ancient trading systems in the world was based on cinnamon originally. So that's the case. Napoleon's buttons itself, the name comes from the fact that Napoleon and his soldiers, he made buttons on the uniforms out of lead. Relatively straightforward lead. Well, when lead gets really, really cold, it becomes brittle and breaks. So think back to what we know about Napoleon and so forth. He started fighting Russia. He invaded Russia. What is the #1 rule about invading Russia? Kind of good. Don't invade Russia in the winter. Okay? He invaded Russia in the winter, and his soldiers were marching on Russia, and it was unbelievably cold. And lead goes through this phase transformation. It changes, basically. It becomes brittle, and all of a sudden the buttons on all of his soldiers' uniforms broke. Now imagine you have thousands and thousands of soldiers out there in the unbelievable cold, and they can't keep their pants up. They literally can't keep their pants up because they don't have buttons. Their jackets won't stay closed and so forth. Imagine what that does to morale and so forth as it goes through. So this simple property of lead, that when it gets really cold it becomes brittle, may have had a huge effect on his march into Russia and so on. So you'll see that from time to time as we go through things. I just lost my train of thought. I was thinking of cold soldiers. I guess that's where I'm going to end this. Now, don't completely pack up because I want to talk about the textbook a little bit. Any questions about that? Okay, so this year we're doing something new. And what it is a textbook. So if you've been to the bookstore to get a copy of the textbook, you'll very quickly realize that there is no textbook at the bookstore, right? For this course. Okay. Did you get that from the bookstore?
Yeah.
Did other people? Okay. Did you? Anyone else? Okay. Return them. Return them. Can you return it?
He said after you take the plastic off, it's like, that's it.
Okay. Well, talk to me after class. Whoever did.
I just wanted to read ahead, so.
What?
I thought I would like start reading.
No. I commend you for it. I wonder why that is. Okay. Now I'm all lost. Here's what we're going to do. This book, it's actually not a book. What it is an electronic book. And if you go to Blackboard, there is this folder here called textbooks. So if you click on that, you're going to come to this. Right here, is the first half of our book in a PDF. So that's what this is right here. It's just the printed out version of it. Go through it just like a normal textbook. It's an electronic version of it. Now, what's nice about this, so if I just click on it here, it's a PDF. What's nice about this is the fact that it is a free textbook. So you don't have to pay anything for it. You can just download it and use it as you will. So what I've done is I've gone and set it up just as if it's the normal textbook. So it goes through, this would be chapter 1, and it's got all the different things that we're going to talk about in chapter 1. So science, alchemy, chemistry, compounds, and so forth as you go through. So here, then, we've got it. So this is just like a normal textbook for you. If you want to print it out, it is literally just like a textbook. Okay? The first half is, I think, about 250 pages. So I would highly recommend not printing it out unless that's kind of your thing. If that is your thing and you want to print it out, go in and shrink all the photos. Okay? That will save you quite a bit of room. And get rid of the cover pages and so forth. I haven't done all that, but I could probably get 25% of it out at that point. So the book is there for you. And you can download it and just simply use it as a PDF, or there is also a study group. The book comes from an organization called CK12. And what CK12 does is they write textbooks that are free for students to use. So I commend them for it. The textbook for this course had been, I want to say a little under $100 for that. Now, the new version that they were going to make me switch to jumped to $200. At that point, I said, enough's enough. I'm not doing that. And that's the reason why I went and I made the separate textbook here, because of the price change associated with it. Now, this is the first semester I've used it, so there are going to be some errors in it and so forth. In the book, the information's all good. I've read through the entire book. I know the information is good. Some of the questions and so forth may be a little bit off. If you find something questionable, let me know. But I think it's going to do what I want it to do. The book is set up so that it takes each section from the old book and basically mirrors it in the new book. Okay? It's got different wording and so forth, but the same flow and everything's the same, so it shouldn't affect things too much. This study group here, if you go to the study group and you copy this and paste this over, it's going to take you to the CK12 page. And this is what the page looks like. Now, you do have to log in, so you have to sign up for it. I don't have any way around that. It's an optional thing because you can always get the PDF otherwise, but if you do go to this and sign in, you're going to see shared resources. Click on it, and here is the textbook. Click on it, and it brings you in. So it's the same thing except as a web version. The only difference is if you go to the individual sections. So here, for example, is one section from the book. Up at the top, it has practice problems for you that you can do. So if you want, you can go in, hit the practice problems. It'll pop up. I got this super large at the moment. And it goes through and it'll ask you questions having to do with that section. Does that make sense? I feel like I'm talking a lot to try and show you the basics of it. So if you go in here, so choose an example of a physical change. Choose all the examples. So this one. Okay, so there you go, and you get immediate feedback on it, whether it's right or wrong for you. This is purely optional, purely practice and so forth. But for some students who want additional ways to practice the questions and so on, they can go ahead and do this here as well. Okay. So that's the story with the book. As I said, the first half is, I forgot roll again. The first half is available for you on Blackboard. So you can go ahead and download it in whatever format you want and so on. Let me know if you have issues. Okay, anything else you guys can think of right now?